Hey guys, welcome to the South PyTech, the Python programming channel. Today we are going to learn the remaining topic of the repetition structures. That is topic 4, 5, 6, and 7, the calculated running total, the sentinels, the input validation loops, and the nested loop. I hope you are struggling and practicing the remaining topics that we have studied in the last video session. So let's start with the topic calculating a running total. Okay. So in the fourth topic, the calculating running total, the concept behind this topic is a running total is a sum of numbers that accumulates with each iteration of a loop. The variable used to keep the running total is called an accumulator. So what happened behind this? When a program is running and you have to add a figure, like if you are withdrawing some money in your from your ATM, and we already know there is some balance in our account. So when you withdraw some money, what does it do in the back end? The money got debited, and it subtract from your original balance. And similarly, this case happened with the credit transaction when you deposit some amount via check or ATM or any other online source. So what does it do? It add the amount into your balance. So how it works today, we will understand this concept, that how this total work while in you are in any store, that we already know that we do transaction, we purchase grocery. So things are working at the back end with the concept of running total. So many program tasks required to calculate the total of a series of a number. For example, suppose we are writing a program that calculates a business total sales for a week. The program read the sales for each day as input and calculate the total of those numbers. Program that calculate the total of a series of numbers typically use two elements: a loop that read each number in the series, a variable that accumulates the total of the number as they read. The variable is used to accumulate the total of the number is called an accumulator. It's often said that the loop keeps running total because it accumulates the total as it reaches each number in the series. Below figure shows the general logic of a loop that calculates a running total. So over here, we are understanding the logic behind for the calculation of a running total. So what happened? We have set an accumulator to a zero with a zero integer value, that is maybe an opening balance. What happened? This is basically a decision box. Is there any number to read? So it asks basically, we normally see this is a while loop. So if we say yes, there is a number, there is the next number. So what happened? The number will accumulate over there, and it will accumulate to uh, the variable that we have assigned initially. So that is basically the reassignment of a variable that we have studied a concept in our first two lectures. If the condition is false, so program terminates. So we will understand this concept by doing some programs in Python. So what happened when the loop finishes? The accumulator will often the total of the numbers that were read by the loop. Notice that the first step in the flowchart is to the set accumulator variable to zero. This is a critical step. Each time the loop reads a number, it adds to the accumulator. If the accumulator starts with the any value other than zero, it will not contain the correct total when the loop finishes. Let's look at the program that calculates a running total. Below program allows the user to enter five numbers and it displays the total of the numbers entered. This program calculates the sum of a series of number entered by the user. So over here we have set a maximum number, that is 5. Initialize accumulator variable. So we are initializing a variable having a variable 0, that is our, let's say, opening balance. Explain that what we are doing. This program calculates the sum of maximum 5 numbers. We have given a range. We are seeing that we are using a for loop, and we know how this range per function can be performed easily, and we have studied earlier. Okay, so over here we will give a 5 numbers in this for loop, and we have given a range that is having 5 number maximum. Number integer. So the loop is checking the number from the user, and we are taking as an integer input, enter the number. So what happened? The total we have already assigned over here. Now we have taken the same variable. What happened? The total value will get changed when the total number that is already initialized with the 0. So 0 plus number that we will give the input over here. So what will happen? The 0 will be added to a number given by the user, and it will accumulate this number over to the total. So total will be reassigned by a new number that will get sum up in this step. Now print the total. So it will print the total variable. Basically this is the variable that it will print, because the print is intended or aligned with the margin with the total, and this is for loop. So let's run and check how this program works. Okay, this program calculates the sum of 5 numbers that you will enter. So in the first phase we will add 2, over then we will add 5, then we will add 1, then 3, and over here again 1. So we can see 2 plus 5 7, plus 8 8 plus 3 11, then 12. So we are expecting the total will be the 12. Okay, nice. We can see the total number is 12. So what happened? In each loop, in every loop, the number is taking input from the user. So in the first case, in the first iteration, we have given the total, we have given the number that is having the value of 2. So 0 is added into 2. What happened? 0 when added into 2, it becomes 2, and this 2 is reassigned over here to the 0 operator, the initial accumulator or the variable. So when we added 5, so what happened? There was already 2 and 5 was added over here. So 5 plus 2, that is 7. So 7 was assigned to this variable, and this variable has reassigned this variable, changed the reassignment variable by the assignment operator to the 7. Then we have added 1. So what happened? When 7 added into the total by number 1, so it changes the variable and reassigned to the 8. And this happened with the 3, making it 11, and then we added 1. So finally when 11 was added into the number that we have given over here, that is 1. So 11 plus 1 12. So the value of the total is 12, and this total have reassigned this initial accumulator with the value of 12, and the total is printing over here with a number that is 12. So this how reassignment operator work within for loop, by giving the range function over here, and we have assigned a limit that the user have to enter maximum number that are 5. So we have assigned over here that is 5. So what happened? The total variable is created by the assignment statement in the accumulator. Notice that it is initialized with the value 0. The for loop does the work for getting number from the user and calculating their total. The program prompts the user to enter number, then assign the input to the number variable. Then the following statement adds number to total. Total is equals to total plus number. After this statement execute, the value referenced by a number variable will be added to the value in the total variable. It's important that we understand how this statement works. First, the interpreter gets the value of the expression on the right side of the operator, with is equals to operator, which is total plus number. Then the value is assigned by the is equals to operator to the total variable. The effect of this statement is that the value of the number variable is added to the variable. When the loop finishes, the total variable will hold the sum of all the numbers that will be added to it. This value is displayed in the print statement of the total value. So this was the concept behind the topic that we are running, the calculating running total. The augmented assignment operator. So what happened? Many programs have assignment statement in which variable is assigned on the left side is equal to operator also appear on the right side of the operator. Here's an example that we can see total is equal to total plus number. So the total is coming to time, let's say total is equal to x. So x is equal to x plus 1. On the right side, the assignment operator is 1 is added to the x. The result is assigned to the x, replacing the value that is x previously referenced effectively. The statement adds 1 to the x. We saw another example of this type of statement in previous program. So total is equal to total plus number, as we all know. The statement assign the value of total plus number to the total. I mentioned before, the effect of this statement is the number is added to the value of the total. Here is one more example, like as I have given already example, like in balance, if you are withdrawing some money from the ATM, so your original balance will be deducted with the amount that you withdraw, then this amount will be reassigned to your original balance over here. So this is how the calculation is working over there. The statement assigns the value of the expression balance in minus withdraw to the balance. The effect of the statement is that withdraw is subtracted from the balance. So over here we can see x is equal to x plus 4. We can read this. They add 4 to x, subtract 3 from x, multiply x by 10, x divided by the 2, that is you will get the 3 if you are adding the number 6. Assign the remainder of x divided by 4 to x. These types of operator are common in programming. For convenience, Python offers a special set of operators designed specifically for these jobs. Below table shows the augmented assignment operators. So what happened if you are assigning 2x over here or giving the two variables, we can assign them by this, by giving, if we are adding the assignment, so we can just type 1 and we can add the plus sign. Over here, if you are subtracting or withdrawing the money, so we can add the minus operator sign over here. If you are multiplying, so we can give the asterisk. If you are dividing, we can give the division. And if you are checking the the remainder, so we can type the percentage. As you can see, the augmented assignment operator do not require the programmer to type the variable name twice. The following statement, total is equal to total plus number, could be written as total plus number, because we are adding this, so we can take the total as a common and we can add the plus number over here. Plus is equal to number. So this is a simple case over here. And similarly, we can also add the balance, and is equals to balance minus withdraw. So balance is coming as a twice time, so we can write this as a balance minus is equals to withdrawal. So we can see this is a quite simple way to calculate the running totals and the running subtraction, vice versa. Okay, so now let's jump to the topic number 5, that is Sentinels. So what is Sentinels? Concept behind a Sentinel is a special value that mark at the end of a sequence value. So basically, Sentinels are in a simple way that if we raise a flag, if we give a program a value, like if I say when a program accepts 0 value from a user, whenever it get a value 0, so it will terminate the program. Like if I say if you got a balance 0, so obviously you will not get the transaction. Let's say if your balance is 0 and you want to withdraw 5,000 amount, so obviously you will not get any amount from your bank or the ATM because you have 0 amount. So we have set a criteria that whenever the balance is 0, so the ATM will give instruction to the user that they don't have enough balance or sufficient balance to withdraw the money. If the flag is not raised or there is no such condition, so obviously the program will go into the negative and the negative number will be displayed over here. So let's jump into the program and let's see what happened. So over here, the program displays a property tax. So tax factor is over here, 0.0065, represent the tax factor. Get the first lot number. Enter the property lot number or 0 to end. So over here, we are giving an option to the user if there is no such lot number. So we can add the 0 over here, and we have given a condition over here when lot number is like a 0. So what happened? We have given a while loop over here. So while loop, we have assigned a while lot number that when lot is not equal to 0. When lot number that we will get over here is not equal to 0, so the program will be running frequently and smoothly over here. So what happened? Let's run the program and check what happened. So if we run this program, and we will see get the property lot number. So enter the property number. If we say lot number 5, so what happened? Enter the property value. If we say $1,000, so what happened? The property tax will be 6.50. So over here we can see we are giving the lot number over here, and once the lot number is recognized 0, the program will terminate it over here. So we have assigned lot number that is not equal to 0, that is basically a flag. And once over here the value of the property or the lot number over here, when it will see the value is becoming 0, or in such case when user will input the value that is equal to 0, so the program will be terminated and end by itself. So this is a flag, or this is a factor that we have assigned over here. So over here we will be entering like lot number 8 and property value until unless when I will type, or when user will type the 0 over here. So once I will type 0, because we have assigned a value over here, this is a flag value or the sentinels over here, so it will terminate the program over here. So when I will press enter, so the program is terminated and ended over here. So you can see we have assigned a value that is 0. So user must know when he have to end or terminate the program, he will enter the 0 value over here and the program will be executed or the terminated over here. The next topic, that is 6 number, input the validation loops. Concept behind the validation loop. Input validation is the process of inspecting data that has been input to the program to make sure it is valid before it is used in computation. Input validation is commonly done when the loop that iterates as long as an input variable reference bad data. If a user provides the bad data as input to a program, the program will be process the bad data, and as a result they produce bad data as output. For example, look into the payroll program and program below and notice what happened in the same run when the user gives a bad data input. So what happened in program, we have to add certain check that, like if I enter some amount of a value that I am purchasing, so the value must be in positive, right? So the value cannot be and can never be in negative. So what happened if I execute this program, we say hours of enter the hours worked in this week. So I entered 40 and hourly pay rate is, let's say, $200. So what happened, it gives a gross pay of $8,000. Okay, so what happened when I enter the value of hours same, that is 40 hours, and I enter mistakenly, I press minus and I enter 200. So what happened, it generate a gross pay of minus 8,000. So this is a bad program, right? Because by user mistakenly we have entered the pay rate in negative, and salary or the pay rate cannot be negative, and we have to add a certain check over here that whenever the value is negative, the program must not execute or raise some error that the user or prompt the user to enter the valid data, because the hourly pay rate can never be negative over here, right? So what happened? Logic contained in input validation loop. So get input is the input bad data. Over here in the initial, we are taking the decision whether the user have entered the valid positive value or negative. So if the value is true or the data is fine, so it will, when the data is bad, so it will display an error message and it will take the input again. So once the input is taking once again with the true data, the positive value, so the program will be executed automated over here. So what happened, over here we are taking get a test score, we are taking a score over here, make sure it is not less than 0. So obviously we know the score over here, or the score the candidate is achieving over here, that will be, and every time that will be greater than 0, and it can never be less than 0, right? So we have taken an assigned while operator over here. We are taking the while function while the score is less than 0, so it will it will prompt the user and it will say to enter a valid score over here. So let's say if I enter 5, so score is over here is the 5. If I enter negative score like -2, so it will say the score cannot be negative, enter the current score. So we will enter the 10 over here. So this is the basically the check, this is the this is the valid program that we are checking our program over here by validating that the value cannot be negative or going in subtract sign, it must be positive. Get the test score, make sure it is not less than or 0 or greater than the 100. As we know that the normally we appear in the exam that start with the value of 0. The marks that we obtain, they are assigned between the 0 and 100 to calculate the percentage. So we know the marks cannot be 101. It will give the error because we have taken a while condition because we are validating this loop. So we are using while condition over here. While score is less than 0 or score, we are using or because we have to correct both condition. We have to check the both condition and we have to use or. We don't need to use the and because we have to check the both condition. While score is less than 0, we have to raise the error, or the score is greater than the 100, we have to raise the error. So if the score is -5, so it will raise the error. We have to enter the value between 0 and 100 because the score obtained or the test score obtained is between 0 and 100. Okay, so below is the loop in above code determines whether the score is less than 0 or greater than 100. If either the true, an error message will be displayed. The user prompt enter the correct score. In the next example, it is a retail, no validation, insert negative amount condition. Okay. So over here we are giving the marker 2.5. Another, we are using the variable to control the loop. We have already understood how to control the loop by the while operator. Here we are taking the small y and capital Y from the user, get the item wholesale price from the user, and calculate the retail marker price, display the retail price, and do this again. So okay, so if I have to enter the negative value, enter the item wholesale cost. Let's say I enter by mistakenly 50. So what happened, this is a bad program because the retail price cannot be negative and there is no such validation loop over here. So do you have another item? Okay, if I say yes, and if I enter the valid value, let's say 60, and it is displaying, do you have another? Okay, so I have to terminate this program over here. No. So you can see this is a bad program. It is taking the negative value from the user and not giving or raising any prompt data, or not doing any prompt message over here to the user to enter the positive value. This is a bad program. Okay. Over here we can see now the program is now validated. How? Because we have assigned while over here. So we are using two while. This is a while for main that we are taking the uh, uh, decision from the user whether to run the program or not, and over here we are taking while to check the wholesale price that the user have entered, it's whether the negative or positive. So over here this is validating the program or the price. So this is a good program and the valid program. So if I enter -50 value over here, it will give error, the cost cannot be negative. Amazing. So this is a valid one. If I enter 50, so you can see the retail price is $1.25. If you want to do another program, okay, yes. Now I will enter the capital Y. If I enter 100, so it has a raise. It has given the answer that 250 is your retail price. If okay, another -40, so it will raise an error. Okay, so now I will terminate this program. So you can see this is a valid program over here. And we have validated by assigning a wholesale price that it can never be less than 0. If in this case the situation is true or the condition is true, it will raise the error because the value is less than 0, and the program will take the wholesale value again from the user. Okay, so I guess this is the last topic, nested loop, right? Yes. So what is nested loop? Okay, nested loop. Concept behind a nested loop that is inside another loop is called a nested loop. A nested loop is a loop that is inside another loop. A clock is a good example of something that works like a nested loop. The second hand, minute hand, and hour hand all spin around the face of the clock. The hour hand, however, only makes one revolution for every 12 minutes of the hand's revolution, and it takes 60 revolution of the second hand for the minute hand to the make one revolution. This means that for every complete revolution of the hour hand, the second hand has a revolve 720 times. Here is a loop that partially simulates a digital clock. It displayed the It displays the second from 0 to 59. For second in range 60, so what happened? We are now calculating the seconds over here. So you see, for second in range 60, it has printed the number up to 59, and after 59 it will go to the 1 minute. Now what happened? For a minute, 1 minute is completed within range 60, but before that it has to perform uh, the second range, that is 60. So what happened? In every 60 minutes it will change the number of minutes. For every 60 second it will change the number of minutes over here. So if I run this program, you see, when the seconds were running, so when it complete one complete revolution, it changes the minute from 0 to 1, and similarly it changed from 1 to 2 after completing 59 revolution within 1 minute. And you see, if I go down, it will be making complete 1 hour over here by making all 15 revolutions over here, 59 revolutions over here into 60. So over here you can see the 59, 59. So 59 seconds are performed, for each and every minute to change. So over here, to make the simulate clock complete, another variable of loop can be added to the counter of hour. So I am not running this program over here. The program will count each second of 24 hour, and it will be running so on and on and on and on. So over here, I am not running this program, and it will take a quite long time to run this program, and it might hang our system or laptop that we are using. So what happened behind the clock simulator? What happened? Start a program. Is there a value in list? If there is a condition is to assign the next value in the hours to the hours variable. Is there another value in the minutes? Yes, assign the next value to the minutes to the list. And there is another loop over here. It is there any value in second list? Yes, assign the next value over. So what happened when 59 revolutions are completing over here? So when it runs 59 times, it changes the value up to 1 for minute. When this minute run to the 59 times, it changed the value of an hour over here. So basically this is the first nested loop of second, the second over here, the minutes, and the third one, the major one, that is the hours one. So this is how clock works in a nested loop. Okay, below program shows another example. It is a program that teacher might use to get average of the student test score. The statement asks the user for number of student and asks for the number of test score per student. The for loop the for loop that begins iterate once for each student. The nested inner loop iterate once for each test score. This program averages test score. It asks the user for the number of student and the number of test score per student. Get the number of student. Okay, over here we are taking the total number of student and their test score. So like if there are 3 test score, so the average will be calculated over here. Let's run this program and check. So let's say if there are 2 students total, and how many students, how many test score, but let's say 3 test score. Now it will take the number of 3 test score of the first candidate over here, and the test of the 3 test score of the second student, that is 90, 70, and 85. So the average for the student number 2 is 681. Over here it is giving the average for the student, that is number 60, and the second of the student, that is in number 2, is having the average of 81.6. So over here we can see the number of student over here. It's checking the over total over here and the number test score right here for a student in the number of range. Now we are taking the for loop with the number of student, and we are assigning the total variable over here, the running total that we have studied earlier in this topic number 6. Over here we are printing the headers and the formatting rules over here, and over here we are assigning the for loop with the range of each number. So what happened? There are two nested loop. Number one, the main student, that is number one, and over here we are taking the test score of each candidate. So there are two nested loop running, and we are running the running total over here, the Sentinels, right over here. Now calculate the average test score for the student. Over here it is calculating the average for the candidate one when it iterates for the first time and displayed the result. And when the loop for the first number of a score will get complete, it goes to the second test number, and once the second test number is completed, then it go third test number, and when all three will be completed, the loop of the first candidate will be completed and it will jump to the range, that is the number the second student over here. So this how work when I enter the two candidates. So what happened, the student number one is executed within a for loop. I enter the three test score over here, and the test score will be averages with the number of 60. Then what happened? The loops of the number of student goes to the second one, and student number two appear over here. So test number of the one over here, I have given the input, the two, and the third test score. And what happened? It gives the average of the third student. So this how the loop is working by doing the averaging of the totals of the average test score by creating a loop and the running total, having the for loop over here. You can see we have also assigned the augmented operation. We can see we are adding the test score to calculate the average total. We have assigned the plus and is equal to over here. Now we have another short programs. In this example, the nested loop. This program displays a rectangular pattern of the asterisk. Okay, we are printing the asterisk in a rectangular pattern. How many rows? Let's say 10. How many column? Let's say 10. So we are printing the rectangle over here. This is just for the for understanding how the loop work, the nested loop basically. This program displays a triangle pattern, base size 8. If you run this, and you see the we are using the range and function and base size over here. Over here the program displays a step pattern, so number of steps 6, and for range in number of steps, and we are printing the hashtag over here. So this was the last example of our topic, the nested loop. This is very important, and we normally use in our programming by making 2 and 3 condition or 3 for loops. So guys, keep watching my videos and subscribe my channel, like, share, and give your comment below. And if you have any feedback or if you want to understand any topic, so do comment below. I will share the Jupyter notebook of this repetition structure. You can perform these exercises from very starting. All exercises and questions are given to this. And thanks for watching. Have a good day.